All right, we're going to go through some notes on factoring. We're going to take a little break from graphing. So, when you are factoring, right now we're focusing on monics, and we'll talk a little bit about what that means. So first, when you have a quadratic function, the square term is the ax squared term. This is when your exponent is a 2. A linear term, in this case bx, the exponent is 1. On the variable, I forgot that part, sorry. And the constant in this case is c. And remember, a constant is a number without a variable. So we're going to go ahead and fill this in, okay, and we're going to be multiplying as well as adding. So here they already use the distributive property to multiply, and we're just going to be simplifying. So we're going to be combining. So our linear term here would be the 2x plus the 3x, which gives us 5x. Here our squared term is x squared. 7 minus 2x gave us 5x, and our constant term is negative 14. In this next case, our squared term is x squared, negative 6x plus 4x gives us a negative 2x, and our c term is negative 24. The final one, we have x squared. Here, q of x plus p of x, we can put the q plus p in parentheses, because that's what we're doing up here when we simplify these other values. And then our last term here is p times q. So the coefficient for the linear term in this general case is when we have p plus q, or q plus p. The commutative property of addition means they're the same. The constant term is p times q. The square term in all of these cases, the coefficient here, is 1. That's why these are called monics, because the coefficient on our squared term is 1. For all monics, all binomials where their coefficient is 1, to find our b value, we add p and q. And to find our c value, we multiply p and q. So we're going to go through a few examples now and show that that will work. So when we flip our paper over, we can see example 1, x squared minus x minus 1. So we need to find values of p and q where the product is negative 6 and the sum is negative 1, because those are my values here. So factors of negative 6, because we have a negative number, we need positive and negatives. So negative 1 and a positive 6, positive 1, negative 6, negative 2, positive 3, positive 2, negative 3. We're going to try integers first and see how that goes. Now we find the sum. So negative 1 plus 6 is 5. 1 plus negative 6 is negative 5. Negative 2 plus 3 is 1. 2 plus negative 3 is negative 1. So for this example, we wanted a product of negative 6. All of these have a product of negative 6. We want a sum of negative 1. The only example here where the sum is negative 1 is our final example here. Therefore, these are the factors. So p is 2, q is negative 3. So I can write my trinomial as x plus 2 times x plus negative 3, or x plus 2 times x minus 3. I want to take a break there. Go ahead and try examples 2, 3, and 4, and then I'll come back with another video.